Okay, so here we go. I'm going to try and demonstrate how to calculate the area of a complex shape. So before we look at the complex shapes, then we should probably review how you get the area of simple shapes. So I'm going to turn the paper over and I'm going to draw what could be a square. I don't have anything to measure, but I'm going to draw it as if it were a square. And then I'm going to draw a rectangle. And then down below we're going to have a triangle. Okay, so to get the area of a square, you'd have to multiply the width times the length. The width is this dimension, the length is that dimension. So if in this square the width, let's say we're 8 inches, and the length is 8 inches, then the area of this square would be 8 times 8, 64 inches squared. Okay, in this rectangle, to get the area of the rectangle, the area would be width times length, the same formula as the same formula for the square. Except now with the rectangle, of course, one dimension is unequal to the other dimension. So let's just say this width is 20 inches, and let's just say this length is 8 inches. Okay, so for the area of the rectangle, this would be 20 times 8, or 160 inches squared. Okay, so now in calculating the area for a triangle, we kind of use the same thing, except this triangle, of course, is not a completed dimension like a square or a rectangle. So what we're actually going to use is the width of the triangle and the length of the triangle. Except when we're talking about triangles, we usually don't use width and length. We use the base and the height. So instead of calling this the width, we're calling this the base and we're calling this the height. So to calculate the area for a triangle, the formula actually is half the base times the height. That gives you the area of a triangle. So let's just say the width of this triangle, or the base, is 8 inches. Let's say the height is 10 inches. So to calculate the area, you'd have half the base times the height. Half of 8 is 4. 4 times 10 is 40. So the area of this triangle would be 40 inches. Okay, 40 inches squared, we should say. Alright, so now this being the base, this being the height, what happens if we flip the triangle? Let's say we were looking at the triangle this way. So I wanted to show you that it really doesn't matter which one of these you call the base or the height. Just remember, you need two dimensions. You need a width and you need a length. So we could call this the base. If the triangle were this way, we could call this the base, and this could be the height. This is the width of the triangle. This is the length, or how tall a triangle is. So we use the same formula, half the base, which this time is 10, times the height, which this time, looking at this triangle, same triangle in this dimension, having it flipped, let's see what we get. 1/2 of 10 is 5. 5 times 8 is 40. Still the same. Now if we flip this triangle this way, and we were looking at it this way, we could call this the base. But now, if this is the base or the width of the triangle this way, we need to know the height. And now we're at this angle. Neither one of these demonstrate the height of the triangle or how tall the triangle is. Rather, is this dimension now. I'd have to draw a line perpendicular, and now this would be the height. This would be the base, or like the width, or how high the triangle is, and this is the height. So now we'd have to use the same formula, except now there's a side that has a missing value, and we don't know the value of this number. So when we're calculating, and I don't think you're going to have to use this in your class, but if we had to, we could calculate the base by using Pythagorean's theorem, but we don't have to do that right now. Okay, so now that we've reviewed that, and we understand base and height, and even if we were doing a rectangle or a square, we could say that the width is the same as saying the base, and the length is the same as saying the height. Okay, so I printed off this worksheet from the website. And so what we're going to do now is calculate the area for a shape that's not a square or a rectangle or a triangle. So what we're going to have to do is, in this complex shape, is just separate the shape into what's more familiar to us: squares, rectangles, or triangles. So we got a lot of ways we could do that. And I think the simplest way is to just use straight lines and no angled lines. You wouldn't want to separate this complex shape by putting in an angle, because then you just get two more complex shapes. You want to separate the complex shape into two simple shapes, like a square or a rectangle or a triangle. So let's just say we're going to separate this complex shape into two by drawing a line here. Okay, so in other words, we have two simple shapes now. We have a small rectangle on the top and a larger rectangle on the bottom. Okay, so now remember, when we calculate the area, we need two dimensions. For a rectangle, we need two dimensions. We need the base and the height, or the width and the length. Width times length, that's going to give us the area. So now we have two simple shapes that make up this complex shape. So we're going to calculate the area for each of the simple shapes. Okay, so some of the dimensions have been given here. We've been given this dimension, this 7 millimeter dimension here, and we could call this the base of this shape. Okay, so now with rectangles and squares, you know, opposite sides, parallel sides, have the same measure. So if this is 7 millimeters, then this is 7 millimeters. From here to here is 7 millimeters. Then since this is a rectangle, that means from here to here also has to be 7 millimeters. Okay, so this dimension is given already. This dimension that's given right here, I'm going to, the way they've typed it here, makes me believe that this dimension, this step right here, is 3 millimeters. From here to there is 3 millimeters, because they typed it close to this line right here. That's why I'm assuming that 3 millimeter means that this piece right here is 3 millimeters. Over here, there's 5 millimeters, because they've typed it here in the middle of this line. Makes me believe that this entire section right here is 5 millimeters. In other words, from here to here is 5 millimeters. The way this is typed right here makes me believe that the 2 millimeters pertains to this area, this portion right here, just this part of the line. From here to there is 2 millimeters. So I'm drawing an arrow going that way. The 3 millimeters pertains to this line here, and the 5 millimeters pertains to this entire line here. Like, this would be the height of this complex shape. The 7 millimeters would be the base or the width of this complex shape. But now remember, we've separated this complex shape into two. So now we're going to work with one shape at a time. Let's work with the upper shape. So this side of this rectangle is 2 millimeters. Remember, with rectangles, the opposite or parallel side has to be the same. So if this side is 2 millimeters from here to there, that means that this side of this rectangle has to be 2 millimeters. That is from here to here. If this side right here from this point to that point is 2 millimeters, then this side from here to here has to be 2 millimeters. So I'm going to write 2 millimeters on the inside. So we understand this 2 millimeters means just this section right here. Okay, so now remember we need 2 dimensions. So for this upper simple shape, we now have 1 dimension. We have the height. What we need is the base or the width. So how can we get the width if they didn't give it to us? There's no number here and there's no number here. Well, now we're going to have to use the bottom shape to help us fill in the blanks. Okay, so in the bottom shape, remember, this 7 millimeters from here to here has to be the same from here to here. This is 7 millimeters. This is 7 millimeters. Now they've given us a portion of the 7 millimeters by putting this 3 millimeters here, which pertains to this point. From this point to this point, that's 3 millimeters. So if this entire segment is 7 millimeters, and this portion of this segment is 3 millimeters, then I need to find out what this portion of the segment is. If this entire thing is 7 millimeters, from here to here is 3 millimeters, then the remainder of this segment has to be 4 millimeters. So I'm going to write 4 millimeters in here, and I'm going to draw an arrow up. So from here to here is 4 millimeters. From here to there is 3 millimeters. That means this entire segment is 7 millimeters, which agrees with the parallel segment, 7 millimeters. So what we really have done is taken the 7 millimeters, subtracted out the 3 millimeters, because that's a portion of the 7 millimeters. I'm going to dot down. This is just a portion of the 7 millimeters, and we've figured out what the rest of this 7 millimeters is by subtracting 3 from 7. This is 4 millimeters. Okay, so now I had to do that now to find the base for this upper shape. So the base is 4 millimeters. Well, if the base is 4 millimeters, that means the opposite parallel side of this shape has to be the same. From here to here is 4 millimeters. From here to here is 4 millimeters. I can fill that in. So now I have every dimension that I need for the upper shape. So the area of the upper shape, remember, is the width times the length, or the base times the height. The base is 4 millimeters, and the height is 2 millimeters. So the area of the upper shape is 8 millimeters squared. Okay, now the lower shape, we need to have 2 dimensions. We have 1 dimension. We have the width of this rectangle, or the base, this 7. Now we need to know what the height, and again, now we're disregarding this upper shape because we've already calculated the area for that. So we're just working with this shape right here. So the width, or the base, is 7 millimeters. The question now is, what is the height? Okay, well, remember over here they gave us the entire length, the entire height of this complex figure as 5 millimeters. And when we were trying to figure out the area of the upper shape, we figured out that this portion, this segment of 5 millimeters is 2 millimeters. So we wrote that 2 on the inside. So now we need to know what this remaining segment of 5 millimeters measures. Okay, this whole thing is 5 millimeters. From here to there is 2 millimeters. From here to there has to be 3 millimeters. I'm going to write that on the inside. This is 3 millimeters. From here to there is 3 millimeters. This entire segment is 3 plus 2, 5 millimeters. So now we've just figured out what the height is of this shape on the bottom. And if this side of this shape is 3 millimeters, that means the opposite side is also 3 millimeters. I'm going to write that on the outside and put an arrow there. So now we have both dimensions. We have the base, 7. We have the height, 3 millimeters. So the area of this shape